Welcome, dear friends. Today we are going to learn about hammer mill, fluid energy mill, ball mill, end runner mill, and edge runner mill. So, first we will see what is exactly hammer mill, on what principle does it work. The hammer mill, it operates on the basic principle of impact between the rapidly moving hammer, which is mounted on a rotor, and the powder material. Now, because of this force of impact, there occurs size reduction of the particles. So, in construction, we can say the hammer mill, it can be either vertical or it can be horizontal shaft type. The hammers, they are made up of hard steel or stainless steel with impact surfaces made up of abrasive resistant material such as hastellite and carbide. The hammers, they can be of different shapes. There are basically two shapes which are used. The first one is bar shaped and the second is stirrup shapes. The bar shaped hammers, they are extensively used in tablet granulation method. The hammer blades, they can be either flat edged or they can be sharp edged or they can be both. So this unit is enclosed within a chamber which contains a removable screen of desired size. Okay, so this is the basic construction of hammer mill. Now you can see here, this is the size reduction chamber. Okay, so what happens, you can see here, it is the hammer, oh sorry, hopper, through which the we can inlet the feed. This is a conveyor screw. Okay, the role of the conveyor screw is to propagate the material inside this size reduction chamber. Okay, now as this this rotor, okay, which is mounted with hammers, it is continuously in motion, and we can see the lower area of the chamber, it is made up of we can say it consists of a screen. Okay, so only the particles which have size less than or nearly equal to this screen, they can pass out. The particles which are over this sieve size, they cannot pass through the sieve screen, and they remain inside this chamber and they continuously undergo hammering or size reduction until the desired particle size is achieved, and then it is removed from this screen. Okay, so now what happens, suppose you are feeding in the material with the help of the conveyor belt. This feed, it moves inside this chamber, and due to the action of this hammering or the hammers, it undergoes particle size reduction, and these small particles, they will fall into this collecting duct through this sieve. Okay, so this is the basic construction and working of a hammer mill. Okay, so you can see here, this is the hopper which is used for feeding. This is a screw feeder. This is a size reduction chamber. Inside it, a rotor is fixed, and the rotor is mounted with hammers, and this hammer is continuously in motion, rotation. Okay, so due to the rotation of this hammers, when the material it comes in contact with this hammer, the hammer is going to have an impact on that particle, and it will result into size reduction. Now the product, the particles which can pass through this sieve, only they are removed from this end, and the remaining particles, they remain inside the chamber, and again they undergo size reduction. So in working, we can say the hammers, they are allowed to be in continuous motion. The RPM is around 8,000 to 15,000. The feed material is placed in the hopper, while while the hammers, they are in continuous motion. The rotating hammer, they beat the material to yield smaller particles, and these particles then pass through the screen. The screens, they are interchangeable according to the desired size of the product. The fineness of the particle, it depends on the speed of the rotor, the feed rate, the clearance present in between the hammer and the grinding plate, the number and type of the hammers, and lastly, it also depends on what is the size of the screen. Okay, so the screen, we can change it according to our desired or what do we need. Okay, so advantage of this hammer mill is that it has got very simple setup, it is very easy to clean and operate, and also maintenance cost is less, as complicated machinery is not involved. Also the operation is continuous process. Okay, you don't have to in between switch off the working, and you don't have to take out the ingredients. Okay, The sieve being detachable, you can use desired sizes as per your need. Okay, so the disadvantage of this equipment is that it cannot be employed to mill sticky and fibrous material. The screens, they may get clogged also. The variants which are available of hammer mill is called as Fidd's mill and Stokes tornado mill. Okay, so these are the variants and these are available in the market as well. So now next we are going to learn about fluid energy meal. The fluid energy meal is also known as jet meal or micronizer or ultrafine grinders. The principle of fluid energy meal is that it operates on the principle of impact and attrition. Now the impact, it occurs in between the powder particle and the surface of the, or we can say the wall of the equipment. And attrition, it occurs in between two particles. Okay, means the two particles of the same powder, they go and they collide with one another, they undergo attrition, and due to this there occurs size reduction. So here size reduction occur by two mechanisms, that is impact and attrition. So in this equipment, the material to be milled is suspended within a high velocity airstream. The milling, it takes place because of high velocity collisions between the suspended particles. Now this is a fluid energy mill, we can say. You can see here it consists of an elliptical tube. Okay, now the diameter of the elliptical tube is the same on all the sides. Here inlet is provided for the solid or the powder particle whose we have to reduce the particle size. Okay, here the fluid inlets, they are projected. Now you have to keep in mind the fluid inlets, they are placed tangentially. Why they are placed tangentially? Because if they are placed vertically, the high velocity of air which we are making, which we will make it to pass into this chamber, it will lose its turbulence. Okay, because if it enters in this direction, it will first collide with this wall and then it will move. Okay, so it will lose its turbulence or its velocity. Okay, so we don't want that. Hence we are going to place the inlets in tangential direction. Okay, now you can see here at one end, we can say a classifier is placed, which helps to remove the fine particles and the fluid. Now here, what is the fluid? The gas or the air which we have passed it through the fluid inlet jet, right? Now what happens when your solid, it enters through this inlet, it comes in this portion. Now when the solid, it comes in this portion, due to this high velocity airstream, there occurs turbulence and the particles, they are moved with very high velocity. Now when the particles, they are moving upwards, they collide with this one, also they collide with themselves. Okay, that is attrition. Now this impact and attrition, it results in size reduction, and both the coarser as well as the fine particles which are formed during collision and impact, they move through this area. Now you can see here there is a curved path. Okay, so when the particle is moving along this curvature, centrifugal force is going to act. Now the centrifugal force, what it does, it will be greater on the coarser particles and it will be lesser on fine particles. Okay, so due to that, the coarser particles, they move along this pathway, whereas the fine particles, they move along this pathway. Okay, now what happens, the fines, they can be removed with the help of the classifier from this side, whereas the coarse particles which were moving from the outer periphery, due to the high centrifugal force acting on them, they again fall into this area, and again the cycle is repeated until they get, or we can say they are reduced to the desired size. Okay, so this is the basic operation of fluid energy mean. Okay, now consider the fluid energy mean. We can say this is the outlet, this is the inlet for compressed air, this is the fluid nozzle, this is the venturi feeder, this is fluid inlet, this is the elliptical loop pipe, and here classifier is fitted, which is either a cyclone separator or a back filter. Okay, now when you feed in the material, the particles, it will fall, it will come into this chamber, and due to the air, what will happen, it will impact. Look, see, it, it is getting collided with the wall. Okay, now again all the particles, they will move, also they will collide with themselves, and this collision and impact, it results into size reduction. Now we can see here the particles, they are not of uniform shape or size. Okay, some particles are coarse while some particles are. Okay, now what happens when these particles, they will move along with the air, the fine particles, they will move along this pathway and they will come out. The coarser particles, due to high centrifugal force, they will flow through this outer curvature, and then again they will come here, and the same cycle will be repeated until they are removed from this outlet. Okay, so this is the working. So we can say in construction, the fluid energy mill, it consists of an elliptical pipe which has the height of about 2 meters and diameter ranging from 20 to 200 mm. Okay, the mill surface, it may be made up of soft stainless steel or tough ceramics. The grinding nozzles, they are placed tangentially to the initial flow path of the powder. The compressed air of pressure around 600 kilopascals to 1 megapascals is used. Inert gases are used to minimize or eliminate the oxidation of the compounds. Venturi feeder is provided in the path of airflow. An outlet with classifier, that is cyclone separator or back filter, is fitted to allow the escape of the air. Now we will see the working. As I told you, the powder is introduced through the inlet of Venturi feeder. The air entering through the grinding nozzles transports the particle in the elliptical or circular track. In the turbulent stream of air, the suspended particles, they collide with each other, and the particles, they break. So thus we can say impact and attrition forces operate in the process of size reduction. The resultant solid particles, they are carried to outlet and they are removed by the cyclone separator. The coarser particles, they will undergo recirculation in the chamber. So these recirculated particles, they again collide with the new incoming feed particles and with the wall of the fluid energy mill. The powder remains in the mill until its size is reduced sufficiently. Later it leaves via the sieves. Okay, so thus fluid energy mill produces particles with narrow size distribution. The particle sizes, they are basically determined by the speed of the air or the inert gas, the feed rate and the size of the particles, the configuration of the mill, design of the classifier, the position of the nozzle, the impact between the feed and the air. Now let us see what are the pharmaceutical uses of fluid energy mill. Fluidized energy is used in milling thermolabile material. Example, sulfonamides, vitamins and antibiotics. So we can say it is a choice of meal when higher degree of drug purity is required. Fluid energy meal is basically used for the fine grinding of frits, kaolin, zircon, titanium and calcium and aluminum. What is the advantage of fluid energy meal? As it has got no moving parts, it will show no tendency of contamination due to the wearing and tearing of the parts. Okay, the equipment, it can be very well sterilized. The small particle size, which is in between 2 to 10, it is usually obtained at the end of the milling. Thermolabile material can be milled with little degradation, since the heat produced by the process is nullified by the cooling effect of the expansion of the compressed gas. Let us see the disadvantages of fluid energy mill. Um, the powders, okay, which are formed after milling in the fluid energy mill, they have a tendency to aggregate or agglomerate after milling. There occurs generation of amorphous content due to high energy impact. There is formation of ultrafine particles, and we can say it is not suitable for milling of soft, tacky materials. Now let us see next meal, and that is ball meal. So these ball meal, they are also called as tumbling meal or pebble mills. The principle of ball meal is that it works on the principle of impact. Okay, now impact, it occurs between the rapidly moving balls and the powder material. Okay, the powder material and the balls, they are both enclosed in a hollow cylinder. So at low speed, the balls, they roll over each other, and in this case, when the balls are only rolling, it will result into attrition. Okay, and here at low speed, attrition will be the mode of size reduction. Okay, so we can say at low speed, ball mill results into attrition. Okay, and then it results into size reduction. Okay, so let us see the construction. The ball mill, it consists of a hollow cylinder which is mounted on a metallic frame in such a way that it can be rotated on its longitudinal axis. The length the length of the cylinder is slightly higher than its diameter. The cylinder is made up of metal lined with rubber or porcelain. The cylinder contains ball that occupy 30 to 50% of the meal volume. The ball size, it depends on the size of the feed and the diameter of the meal. Balls are made up of steel, iron or stoneware and act as grinding medium. Now let us see the working. The drug which is to be ground, okay, it is put into the cylinder of the meal in such a quantity that it has to fill about 60% of the volume of the meal. A fixed number of balls, they are introduced and the cylinder is closed and the meal is allowed to rotate on its longitudinal axis. The speed of rotation is very important. So if the speed is very low, the balls, they will only slide on this wall and this will result into attrition. When the speed is very high, then due to the centrifugal force, the ball will get aligned towards the wall and there will occur no impact and attrition. Okay, so what we have to do, what we want, that the balls, they should rise up to a particular distance along with this movement of the meal, and the balls, they should fall down. Okay, now when the balls, they will fall down on the powder bed, this will result into impact. Okay, so this is the correct speed and the correct speed is called as the critical speed of ball mill. Okay, now let us see how it works. When the ball mill is rotating, the balls, they are also rotating with the mill, so the balls, they get uplifted and they will slide or they will fall on the powder bed and this will result into particle size reduction due to impact and attrition. So now let us see the use of ball mill. It can be used for fine grinding with the particle size of the range of 100 to 5 or less, for production of ophthalmic and parenteral products. So we can say it can be used for the preparation of sterile dosage forms. Okay, for milling dyes, pigments and insecticides at low speed. For that also we can use ball mill. What is the advantage of this? It can produce very fine powder. Ball mill is used for both wet and fine dry grinding processes. Toxic substances can be ground because the cylinder is closed and no toxic dust will be given out. Rod or bars, they can be also used as grinding media. The installation, operation and labor cost which is involved in the operation of ball mill is very low. As the mill is closed system, it can be used for the production of sterile products and oxygen sensitive products. Also, it is used for batch operation and it can be made by some modification. We can make it to operate for continuous type also. The disadvantage of ball mill is that it is a very noisy machine. Okay, why it is noisy? Because the balls, they rise up to a certain distance and then they fall. Okay, so in this process a lot of noise is created. Also the balls, as they are falling, there occurs wearing from the ball and there is a chance that it might result into contamination of the product. The ball mill is a very slow process. You cannot mill soft and fibrous material in ball mill. The variants of ball mill include Herdinge mill and continuous ball mill, vibrating ball mill. Now let us see edge runner mill. The principle of edge runner mill is that size reduction occurs by crushing due to heavy weight of the stones. Okay, so we can say edge runner mill, it is a modification of mortar and pestle. Okay, so here occurs crushing. The shearing is also seen due to the movement of the rollers. The construction of edge runner mill involved, it consists of two heavy rollers and these rollers, they weigh several tons. The roller, it moves on a bed which is made up of granite or stone. Each roller has a central shaft. Okay, and it revolves on its axis. Okay, so we can say the rollers, as they are mounted on the horizontal shaft and they move around the bed. Okay, now the rollers, they are rotating as well as they are revolving due to that shaft. Okay, so this is the construction of edge runner mill. You can see here these are the two rollers. Okay, now these rolls, they are rotating because of this shaft. Also this shaft is rotating. Okay, so we can say these rollers, they revolve in this bed. Okay, now this is the bed, this is the base, and inside this base we are going to add our material, right? So you can see here the working, sorry, the edge runner mean these are the rollers, they are rotating as well as due to this shaft they are revolving, and a scraper is attached. This is a scraper. What is the role of the scraper? To remove the material which falls, which makes a wall around this vessel wall. Okay, so the material is continuously removed and that material comes under these rollers, and there occurs crushing, and due to that crushing there occurs size reduction. Now let us see the working. The material which is to be ground, it is placed in the bed with the help of a scraper in such a way that it comes in the path of the stone wheel. These stones, they revolve on its own axis, and at the same time they travel around the shallow stone bed. The material is ground for definite period of time. The powder is collected and passed through a sieve to get powder of required size. The use of edge runner meal is that it is used for grinding tough materials. It is used for plant-based products. The advantage of this meal is that it does not require attention during its operation. The disadvantage is that it occupies more space. Also, contamination with roller material is possible. It is a time consuming process. It is not used for sticky materials. Energy consumption is higher as compared to other equipments. Now we will see our last meal, and that is end runner meal. The principle is that here size reduction is done by crushing due to the presence of heavy weight steel pestle. Shearing is also seen during movement of the mortar and pestle. Its construction includes that it is a mechanical mortar and pestle. It consists of a steel mortar which is fixed to a plate. The construction of mortar is connected to horizontal shaft bearing a pulley so that a plate with mortar can be rotated at high speed. The pestle is dumbbell shaped and bottom is flat. The construction of pestle is done in such a way that it can be raised from mortar for cleaning and emptying purpose. Now this is the end runner meal. You can see here this bed. Okay, we can call it as a motor, and as it is made up of steel, we are calling it as steel motor, right? Now this is a dumbbell shaped bell. Okay, a dumbbell shaped pestle. This is connected to a shaft, and also it is connected to an arm. Okay, just like our um, some blenders which we have at home. When we open or when we open them, this pestle, it can come out and you can empty the contents or you can clean it. Okay, now this is the bed of the material. You can feed in the material. It is a flanked plate which is going to support the bed, and this is beveled cogged fitting, and it is connected to a motor. Okay, so due to the rotation of this pestle and rotation of this motor, there occurs size reduction by crushing. So this is the actual industrial or lab scale end runner wheel. So the working involves the material which is to be ground, it is placed in the motor. The scraper, it puts the material in the path of the pestle. The motor, it revolves at very high speed, and the pestle is placed in the motor. The revolving motor causes pestle to revolve too. And due to this, the material, it gets crushed and sheared, and the material is collected and it is passed through a sieve to get the powder of desired size. The use of this end runner meal is that it is suitable for fine grinding. The disadvantage is that it is not suitable for drugs which are in unbroken or slightly broken form. So this was all about the meals which we commonly use in pharmaceutical industry. Thank you for watching.